Hi students, this is a video on solving systems by substitution. Now, when I say systems, I'm talking about system of equations. A system of equations is two or more equations considered simultaneously. Okay, so we're going to be focusing on a system of equations with only two variables, x and y. Okay, and these are going to be linear systems of equations, which means each one is actually going to be a line if you graphed it. We aren't going to have to graph it, but it's a linear system, which means it's made up of two lines. Okay, so let's do an example of solving a linear system of equations by substitution. Now, substitution is the first method that we're going to learn about in this video, and then in a later video I'll show you the addition method, which is another approach. Okay, so example, solve the linear system of equations. Solve the linear system of equations by substitution. Or, in other words, by using the substitution method. Okay. All right. So, again, linear system. Linear just means that each equation is a line. And then system of equations means that it's two or more equations considered at the same time. So for our first example, we're going to have two equations in x and y, but we're going to consider them both at the same time. So the first equation is going to be x plus y equals 15. Okay, and then the second equation is x equals 4y. Okay, so the second equation is x equals 4y. All right, so this is called a linear system because the word linear has the word line built into it. And if you'll notice, each of these equations don't have exponents, so each of these are actually just lines. They're going to be diagonal lines, and where they intersect is actually going to be the solution. But rather than graphing them, we're not really going to be graphing them. Instead, we're going to be using the substitution method. Now, the reason it's called the substitution method is you take one equation and you plug it into the other equation. And plugging it in is substituting an expression into the other equation. Okay, so substitution method. How does this work? Well, you've got your two equations here. And then the substitution method starts with substitution method. Your first step is to solve one equation for one variable. Okay, so solve one equation for one variable. And then plug in to the other equation. Okay, when I say plug in, I mean plug in the expression that you have. Okay, that's the first step of the substitution method. Now the thing is, if one of the equations is already solved for one variable, we don't have to do that part. Okay, so like with this one, if we look at the top equation, it isn't solved because x and y are both on the left side. But if we look at the bottom equation, this bottom equation is actually already solved for x. Okay, this one is already solved for x. Okay? Which means in our first step here, we don't have to solve one equation for one variable. We just need to plug in. Okay, so what do I mean by plug in? Well, we have x equals 4y, and I have to plug that into the other equation. Now, you can't plug it into the same equation because stuff will not work out. You'll get nonsense. Okay, so you have to plug it in to the other equation. So what I do is I take 4y, and I plug that in for x in the other equation. Okay? So the bottom equation was already solved for x, so we didn't have to do that. And now I'm plugging in the expression on the other side, 4y, in for x in the other equation. So instead of x plus y equals 15, we're actually going to have 4y plus y equals 15. Okay? So we're going to have 4y plus y equals 15. Again, how did we get that? Well, we just took 4y and we plugged it in for x in the other equation. So we plugged it into this first equation here. Okay? And then what you have to do is after you plug that into the other equation, then you solve. Okay? So step 2 is going to be solve the equation. So that's going to be the equation from step 1. Okay? So how do we solve this equation? Well, 4y plus y is 5y, right? Because this is 4y plus 1y. So 4 plus 1 is 5y. So we actually get 5y equals 15. And then if we divide both sides by 5, so if I divide both sides by 5, then we're just going to get y equals 15 divided by 5, which is 3. Okay, so we get y equals 3. Okay, now what you can do here is because you have a value for y, you can go ahead and underline this. So this is actually, we just solved the equation for y. Now the thing is, the original system didn't just have a y. It also had an x. So we aren't completely done with the problem. We're about half done. Okay, we're about half done because we solved for y. So now we know that y equals 3, but we still have to determine the other variable, x. Because if you have an equation, a system of equations in 2 variables, you have to find the value of both variables. Okay? All right, so we solved the equation and we got y equals 3. That was step 2. And then what do we do with this? Well, now we're going to go ahead and plug in y equals 3 into one of the original equations to find the other variable, x. Okay? Okay, so step 3 is going to be plug in the value, so plug in the value from step 2 into one of the original equations and solve. Okay, so we're going to plug in the value from step 2 into one of the original equations and solve. Okay, and when I say solve, because we know what y is now, when we plug this into one of the original equations, we're actually going to be able to solve for the other variable, which in this case happens to be x. Okay, so what we're going to be doing here is we're going to be plugging in y equals 3 into one of the original equations, and we're going to solve for x. Now, which one do we want to plug it into? That's the question, right? Well, you want to be smart about this. If I plug it into the top equation, I'm still going to have to solve for x, because here I'm going to have a 3, and then I'm going to have to subtract 3 from both sides. So it's actually probably easier to use the bottom equation. Okay, so I'm actually going to use the bottom equation, which is x equals 4y, but I'm going to replace this y with what we're plugging in, which is 3. Okay, so what are we going to get? We're going to get, the original equation was x equals 4y, and that's actually now going to become x equals 4 times 3. So that 3 I just plugged in for y, because we already solved in the previous step. We figured out that y equals 3. Okay, and then 4 times 3 is 12. Okay, so that gives us x equals 12. And I'm going to go ahead and underline that. So now we know both x and y. So we're almost done with the problem. The only thing we have left to do is, for your homework and for the quiz, you have to write your answer in a certain way. So because this is a system of equations, or in short, just a system, you need to write your answer in the form x comma y. Okay, so we need to write our answer. Write your answer in the form x comma y. And that's assuming that when you solved it, you actually got an answer. Now, there are some rare problems where there will be no solution, so you would write no solution. And there are some other rare problems where you would have an infinite number of solutions. But for most problems, you're going to have what's called an independent system, which means you're going to have an answer for x and an answer for y. So you want to write your answer in the form x comma y. Okay, so here, our x comma y is going to be, for this problem, 12 comma 3. So it's actually a point. Okay, so 12 comma 3. So remember, x comma y is actually a point. And even though we're not going to be really graphing these, it is nice to know what's going on here. So you could have graphed these equations at the beginning, and you can use a graphing calculator to actually figure out the solution by figuring out where the two lines intersect. Because it's linear, each of these equations are lines. Okay, so the top equation is a line, and the bottom equation is also a line. Okay, so where those two lines intersect is a point, and that point is called the solution, because that's a point x comma y. That's the solution. Okay, and even though we're not going to be doing the graphing thing because it's tedious and difficult to do on a computer, you can use graphing calculators to solve these, but it takes the fun out of it. So anyway, what this represents, though, this point represents the solution okay, the solution, which is the point where the lines intersect. Okay, it's the point where the lines intersect. So there's two lines. I'm not going to bother to graph them, but if you did graph them and you were really good at drawing them, you would be able to see that exactly where those two lines intersect is 12 comma 3. And you can also use a graphing calculator if you want to plug them both in and then find the intersection. But I'd rather show you how to actually do the math by hand, because that's what we're supposed to be learning here. Okay? And again, the reason they call this the substitution method is because you're taking a value and plugging it into the other equation, and then you're plugging that value into an original equation as well. So that whole plugging in is also considered substituting or substitution. because you're substituting one value into another equation. So it's the substitution method. Okay, so that was a pretty easy one. Now, because these problems are long, I'm not going to do an example similar to every single homework problem. So what I'm going to do now, since I've done an easy one, is I'm going to jump ahead and do some harder ones. Now, these don't get too hard for the most part, but, you know, they can get harder than this, that's for sure. Okay, so example number 2, problem number 2. So on your homework, I'm looking at your homework right now. The first 2 problems are very easy, so you should be good for those. And the third problem is also not too bad. But I did want to do the third problem in case you don't remember how to distribute. Okay? So I'm going to do an example that's similar to your third homework problem. Okay? So for this one, we have y equals 3x plus 1. Y equals 3x plus 1. That's our first equation. And our second equation is 3y minus 5x equals 11. Okay, and I'm putting this little curly brace on the left side, this thing right here. It kind of looks like a parentheses, but it's curly. That's just to show that we're considering both of these equations together as a system. Okay, so again, we're going to solve this by substitution. Now, what's our first step for substitution? Well, we said the first step for substitution is to solve one of the equations for one variable and plug in the expression into the other equation. Okay, so here, well, which of these 2 equations is already solved? We can see the top equation is already solved for y. Okay, so this one is already solved for y. So that's going to be the one that we want to use here. Okay, we want to use the equation that's already solved. On the last problem, it happened to be x that it was solved for. This one is already solved for y. So what do? Well, we're going to substitute or plug in. So we're going to plug in 3x plus 1 in for y in the other equation. Okay? And the reason I'm doing this example is it's a little bit trickier because 3x plus 1 actually has 2 terms, so we have to put parentheses around it. Okay, so this second equation is now going to become 3 times parentheses 3x plus 1 minus 5x equals 11. Okay, so what did I do there? I noticed that the top equation was already solved for y. So then I plugged in 3x plus 1 for y into the other equation. Okay, and that was my first step. That was step 1. And now we have 3 times the quantity 3x plus 1 minus 5x equals 11. Notice that there's parentheses here. That is very important. If you're ever plugging something in or substituting something that has more than one term, you always have to put parentheses around it. Same thing goes if it has a minus. Okay? But as long as you put the parentheses there, hopefully you'll remember that you actually have to distribute this 3 to the 3x plus 1. Okay, so that's what we're going to do. We're going to distribute this 3 to the 3x plus 1. Why are we doing that? Well, we're going to have to solve this new equation here for x. And when you're solving an equation, the first thing you do is distribute and then you combine like terms. Okay, so when we distribute the 3 there, we're going to get 3 times 3x is 9x. And then 3 times 1 is 3. So we have 9x plus 3 minus 5x equals 11. Okay? And then what can we do from here? Well, combining like terms, we have the 9x minus 5x. Well, 9 minus 5 is 4. So we're going to have 4x plus 3 on the left side. Okay, so 4x plus 3 equals 11. Okay, and then we want to finish solving this for x. So how do we solve this for x? Well, first we need to get rid of the positive 3. So how do we do that? Well, we subtract 3 from both sides. Okay, so if we minus 3 from both sides, we get 4x equals 11 minus 3, which is 8. And then to finish solving for x, I have to divide both sides by 4. Okay, so if I divide both sides by 4, I get x equals 8 divided by 4, which is 2. Okay? All right, so that one was a lot more work, and we're not done. Remember, we just solved for one of the variables, so this time we found x first, but we still don't know y. So how are we going to find y? Well, we're going to have to plug in x equals 2 into one of the original equations so that we can solve for y. So now, which equation should we plug in x equals 2 into? Well, if we go back up here, if I plug in 2 into the bottom equation, that one would be hard to solve for y, because we would have to move this over to that side and then divide by 3. So it would be much smarter to use the top equation. So the top equation is y equals 3x plus 1. Okay, so the top equation is y equals 3x plus 1. And what do we do with this? Well, we're going to go ahead and plug in x equals 2 into this equation. So we're going to substitute 2 for x. Okay, so this equation is now going to become y equals 3 times 2 plus 1. Okay, and 3 times 2 is 6. Right, so we have 6 plus 1, which is 7. So we get y equals 7. All right, and I'm going to go ahead and underline that. So now we have a value for x and a value for y. So our answer is going to be in the form x comma y. Okay. So our answer is going to be in the form x comma y. So here that's going to be 2 comma 7. And remember, the order does matter for a point. So make sure that's actually in the form x comma y. So you have to write your x first and your y second. Okay? And by the way, you can check these, but I'm not going to make anyone check them. The easiest way to check them is to plug in these values for x and y into each of the original equations and then make sure that the equations are true. However, this takes a long time, so if you're checking it, it might be just as fast to look through all of your steps and make sure that you did each step correctly. And of course, the nice thing about my math lab is it's going to tell you whether you're right or wrong. So if it says you're wrong, that means you need to read through your work and figure out what you did wrong. Okay? All right, cool. So that was a little bit harder one. Okay, so let's take a look at example number 3. Now for example number 3, it's a little bit of an odd problem. A little bit of a strange problem. So at first glance, it doesn't seem that hard. So it's just y equals 2x plus 9 is our first equation. And then our second equation is y equals 7x plus 10. Okay, and once again, for every problem in this section, they want us to do it by substitution. So we're going to look at one of these equations. Well, interestingly enough, both of them are already solved for y. Okay, but that's actually going to make it easier, right? So for example, I could choose the top one, and the top one's already solved for y. So I can plug in 2x plus 9 from the top equation in for y in the bottom equation. Okay, so what's that new equation going to be? We're going to have 2x plus 9 is equal to 7x plus 10. That's what the bottom equation is going to become. Now, out of habit, I put parentheses around the 2x plus 9 because it has more than one term. However, because we're just adding on the left side, we don't need these parentheses. Okay, so I'm going to go ahead and erase those. So we have 2x plus 9 equals 7x plus 10. And so far, so good, right? It's a little bit strange the way it's set up, but you would think it would be an easy problem. Okay, so what do we have to do now? You have to remember how to solve an equation like this. So if you have a variable on both sides, you have to pick a side and get rid of the variable. So the way I usually teach my students is it's usually easier to get rid of whichever coefficient is smaller. So on this problem, 2x is a smaller coefficient than 7x, so we're going to get rid of the 2x. So how do we get rid of 2x? Well, we're going to go ahead and minus 2x from both sides. Okay, so we're going to minus 2x from both sides. So on the left side, we're just going to be left with 9, and then on the right side, 7x minus 2x is 5x. So we have 9 equals 5x plus 10. Okay, and then we need to finish solving for x. So how do we solve for x here? Well, we're going to have to get rid of the positive 10 on the right side. So how do we do that? We subtract 10 from both sides. So we're going to minus 10 from both sides. So on the left side, I get negative 1. And then on the right side, I get 5x. Okay, and then what do we do from here? Well, we have to get rid of the 5 so that x is by itself. So how do we get rid of the 5? We have to divide both sides by 5. Okay, so I'm going to go ahead and divide both sides by 5. Okay, so on the right side, the 5s are going to cancel. On the left side, unfortunately, we have a fraction. And that's why I'm doing this problem, because whenever someone sees a fraction, they freak out. I'm sure you guys freaked out when we had those lessons on fractions a couple weeks ago. But, you know, what are you going to do? Fractions are important, and they show up in the real world. Okay, so what we got here is x equals negative 1/5. I went ahead and I factored the minus out front. So it's negative 1/5. Okay, and that's okay. Your answer can have fractions. So we have x now. So now we need to find y. And unfortunately, we're going to have to plug in a fraction of negative 1/5 in for x into one of the original equations in order to solve for y. Okay, so which equation are we going to choose? Well, it doesn't really matter here which one you choose. I'm not really sure which one would be any easier. I'm just going to choose the top one because it looks like it has smaller coefficients, but you could also choose the bottom one. So the top one is y equals 2x plus 9. Okay, so y equals 2x plus 9. And then we're going to go ahead and substitute our value for x. So we're going to be plugging in negative 1/5 for x here. Okay, so now we're going to have y equals 2 times negative 1/5 plus 9. Now, how do you do 2 times negative 1/5? People always forget fractions. Well, remember that 2 is the same as 2 over 1, because if they don't write the denominator, it's automatically 1. Okay, so this is going to be 2 over 1 times negative 1/5. And how do you multiply fractions? You multiply straight across. So on the top, we're going to have 2 times 1, which is 2. And then on the bottom, we're going to have 1 times 5, which is 5. And then we still have a minus out front. So we actually have y equals negative 2/5 plus 9. Now this 9 is the same as 9 over 1. Right? Because once again, if they don't write the denominator, it's always 1. Okay, so what do we have to do to finish solving for y here? We can't just leave it like this. Well, remember, when you have fractions that have different denominators, you have to build them so that they get the same denominator. So here, I have a 5, and there I have a 1. So what do I need to multiply this one by so that I have the same denominator? Well, obviously a 5, right? So we're going to multiply the second fraction by 5, but you have to multiply on both the top and the bottom. Okay? So that second fraction there is going to become 9 times 5 is 45 over 5. And the first fraction is still negative 2 over 5. So we have negative 2 over 5 plus 45 over 5. All right, and now that these have the same denominators, we keep the denominators and we subtract. So we're doing 45 minus 2 on the top. They're opposite signs, so we're subtracting. So 45 minus 2 is 43. So we actually have 43 over 5, and that's actually y. And believe it or not, that's what they got on my math lab as well. So we did it correctly. And of course, if the fraction's not in lowest terms, you're going to have to divide the top and the bottom by common factors until there's no more common factors. But here, 43 is not divisible by 5, so we just leave it as 43 over 5. Okay, and then of course, how do we write our answer? Our answer has to be written in the form x comma y. So on this problem, we said that x was negative 1/5, and then we just found that y is 43 over 5. So we're going to have negative 1/5, comma, 43 over 5. That's our x comma y. All right, and that's the solution. Okay, pretty cool, huh? Okay, so that was one with fractions. I know fractions can be scary, but we did them. We got through them. So looking through your homework, most of these other problems shouldn't give you too much trouble. I did want to do one that wasn't solved, though, because that can be a little bit harder. Okay, so let me go ahead and do this equation. This one's a little bit of a strange one, a little different from the others. Okay, so this is going to be example number 4. So for example number 4, we have 12x plus 6y equals 23. Okay, 12x plus 6y equals 23. And then the second equation is negative 2x equals y plus 4. Okay, so 12x plus 6y equals 23, and then negative 2x plus equals y plus 4. Excuse me, I misspoke. Okay. Remember, what is our first step? Let's go back up to the directions in our first step. What's the first step when you're solving by substitution? It's way back up here. I said solve one equation for one variable, then plug into the other equation. Well, on all the other problems we've done so far, one equation was already solved for a variable, so we didn't have to do that. But this time, we finally do have to solve one equation for one variable. Then we're going to plug that into the other equation. Okay, so now we actually have to do that. This is the first time we've had to do that. Now, of course, there's always an easier way and a harder way. The harder way would be to choose the top equation. The top equation is hard to solve for because, first of all, both x and y have coefficients that aren't 1. So, and also x and y are both on the same side. So you would not want to choose the top equation. That would be too much extra work, and it's just a waste of time. You want to choose the bottom equation. And then it's a question of, well, which variable do I isolate? Well, remember, you want to just have a variable by itself. You don't want to have a coefficient. Okay, so you wouldn't want to isolate the negative 2x because then you'd end up having to divide by negative 2. So what I would recommend is that we isolate the y. So how do we isolate y? Well, all we have to do is get rid of the positive 4 on the right side. Okay, so here we're actually just going to minus 4 from both sides on the second equation. Okay, so then on the left side, we're going to have negative 2x minus 4. And then on the right side, we're just going to have y. Okay, so we have negative 2x minus 4 equals y. Now you could have solved for x here, but then you would end up having to divide both sides by negative 2, and you'd have to deal with fractions. So that probably wouldn't be as nice as the way I did it. I saw that there was a y there, and it doesn't even have a coefficient, so I got rid of everything on that side, and now y is actually isolated, so we're good. Okay, so this one is now solved for y. Now this is solved for y. Okay, so we're still in the first step though. So what do we do now? We go ahead and plug in this expression, negative 2x minus 4, in for y in the other equation. Now I know it's tempting to plug it in to the same equation, but you don't want to do that because it's not going to give you an answer that means anything. So we have to plug in negative 2x minus 4 for y into the other equation. So up here, we're going to have 12x plus 6y equals 23, but we're going to replace that y with negative 2x minus 4. Okay, so what are we going to get? Well, the top equation is now going to be 12x plus 6 times negative 2x minus 4. And notice, because negative 2x minus 4 has more than one term, I put parentheses around it so that the 6 right here will distribute to each of those terms. That's important. You don't want to forget that. Otherwise, you get the wrong answer. Okay, so we have 12x plus 6 times the quantity negative 2x minus 4 equals 23. So this one's a lot more messy. There's a lot more numbers and letters and everything going everywhere. Okay, so we've substituted, but now we need to solve this equation. And if we solve this, we're going to see something weird that we haven't seen before. So obviously you want to distribute first, so we're going to distribute the 6 first. So distributing the 6 to each term, 6 times negative 2x is going to give us negative 12x, and then 6 times negative 4 is going to give us negative 24. So we're going to have negative 12x minus 24. Okay, and don't forget we still have a positive 12x over here. And then on the other side we have equals 23. Okay, now get ready for the weird part. We're trying to solve for x here, but we should notice on the left side we have like terms. So we actually have 12x and negative 12x. Those are like terms. But they have the same number and they're opposites. So 12 minus 12 is 0. And 0x is just 0. So these just cancel out. And there's no more x's left on the left side. So we get the weirdest thing here. We get negative 24 equals 23. So what on earth do we do? Is this an answer? What does this mean? Well, what this is this is never true. Negative 24 and positive 23 are different numbers, so this is never true. So this is never true, but that's not what we write as our answer. I just wanted to point out to you that this is never true, because they're different numbers. It's like saying 0 equals 1. Negative 24 does not equal 23. So if it's never true, what that means is these lines remember, we're actually looking at the location where two lines intersect. If it's never true, then that means the lines never intersect. So it's actually going to be parallel lines, which means because they never intersect, these parallel lines have no solution. Because they don't intersect, so there's no solution. Okay? So if it's never true, there's no place for them to intersect. And so the places where they intersect are the solutions. And so if they never intersect, there's no solution. And that's actually what you write as your answer. Okay. Now there's a little bit more. When you look on My Math Lab, you're going to be clicking the button that says there is no solution. Okay. So there is no solution. I like to just say no solution, but on My Math Lab they say there is no solution. Okay, and how do you write that in math? Well, normally some people would just write no solution, but on My Math Lab they add in some stuff. They say there is no solution, and then they write this special notation. So they write a semicolon, okay, and then they write your answer is actually in the form of the empty set. Because there's no solution, you can either write two curly braces like this, or you can write, it looks kind of like the no smoking symbol, but there's not a cigarette in the middle. So it's an O with a slash through it, a diagonal slash through it. Okay, so for your answer, that's actually how they're going to write it. But fortunately, you're not going to have to type any of this. If you come into this situation on your homework, which you will, you just click the button. There's a button that actually says all this. But I did want to talk about what it means. So because this is never true, that's called a contradiction. So that means the lines never intersect because they're parallel. So there's no solution. So what this business over here means is this is just like with inequalities where you have a solution set, okay? And these are both empty. So these are called, these two symbols here both mean the empty set. And the empty set is basically, think of it as a box with nothing in it. So an empty box. So that just means there's no solution because here's your box, which is supposed to have your solutions, but it's empty. It's an empty set, so there's no solution. So hopefully that makes sense. That's just math notation. But hopefully you're good there. And then for your homework, there was just one more type of problem. So I wanted to do a problem where, so we had ones where there was a solution, an x comma y, and now we've done one where there's no solution, but there's actually one more case. Okay, there's one more case. And the last case would be, well, the standard case is where they intersect at one point. That's where you have one solution. This is the case that we just did was no solution, so they're parallel lines. Well, the last case is if the lines are right on top of each other. So if the lines are right on top of each other, how many solutions are they going to have? Well, they're going to intersect over and over and over again at an infinite number of points. So they're going to have infinitely many solutions. So I wanted to show you an example of that. Okay, so one more example. This is going to be basically the hardest one on your homework because it's the only one that starts with a fraction. Okay, so this is going to be example number 5. Example number 5 is 1/4 x minus y equals 4. Okay, and then x minus 4y equals 16. Okay, so 1/4 x minus y equals 4, and x minus 4y equals 16. All right, so here we do have a fraction to start off with, which can be annoying for a lot of people. However, we can still work with this. What I would recommend is that you don't deal with the one that has the fraction. I would recommend that you try to solve the other equation. Now, if they both had fractions, then we would be out of luck, right? But since the second equation doesn't have a fraction, it'll be less work if we choose the second equation. So we're going to take this second equation, and we need to solve it for one of the variables. So the question is, which variable is easier to solve for here? Well, definitely x, because y actually has a -4 multiplied times it, so that would be way more work to solve for, and we would get fractions. Okay, but if we choose x to solve for, that's the easiest. So we're going to take this second equation and isolate x. So how do we isolate x here? Well, to get rid of the -4y, we just need to add 4y to both sides. Okay, so we get x equals 4y plus 16. Okay, x equals 4y plus 16. All right, and as you can see, I took the smart approach, and I chose the equation that didn't have fractions, and I also chose a variable that was easy to solve for, so I didn't have any fractions yet. Okay, so now this second equation is solved, and it's solved for x. Okay, so this one is considered solved for x. So remember, with the substitution method, what you do is you substitute this expression into the other equation. So we're going to be plugging in 4y plus 16 in for x into the top equation. So we're going to replace or substitute 4y plus 16 for x. So now what we're going to have is we're going to have 1/4 times x. So that's going to be 1/4 times parentheses 4y plus 16 minus y equals 4. Okay? So 1/4 times a quantity 4y plus 16 so I put parentheses around 4y plus 16 because it has more than one term. And then we have minus y equals 4. Okay, so minus y equals 4. So now what do we do from here? We need to go ahead and distribute the 1/4. So when we distribute the 1/4, everyone hates fractions, right? But fortunately, stuff is going to cancel out here. So we're going to have 1/4 times 4, which is going to be 4 over 4 y, plus 1/4 times 16, which is 16 over 4, minus y equals 4. Okay, so 4 over 4 is 1. So we actually have y plus 16 divided by 4 is 4, minus y equals 4. Okay, and then, all right, so, I mean, what we would think we would do here is just combine like terms on the left side and everything will be fine, right? Well, everything won't be fine here. So what's going on is, on the left side, we actually have y minus y as like terms, but those are opposites. That's the same as 1y minus 1y, and 1 minus 1 is 0y. Okay, and 0 times any number is just 0. So on the left side, all we're left with is 4, and on the right side, we also have 4. Okay, so you might think, oh, well, is this just like the last example that he did? Like in the last example I did, was it like this? Well, let's see. Let's look at the last one. On the last example, we got an equation that is never true. Why is it never true? Well, negative 24 and positive 23 are different numbers, so they're never equal. So that was never true, so that meant there was no solution. Now, is this one never true? 4 equals 4. Actually, it's always true. It's the reverse. So not only is this not never true, this is always true. Because 4 always equals itself. It's the same number. Okay, so this one is actually always true. I'll put that in parentheses because that's an important thing to notice. So if you get an equation like that at the end that's always true, then that's going to mean that the lines are actually right on top of each other. They're almost the same line. You can think of them as the same line because they're going to be on top of each other, so they're going to have an infinite number of points of intersection. Okay, so what we say is since it's always true, that means they're basically the same line. Okay, so what we write is there are infinitely many solutions. There are infinitely many solutions. Okay? And infinitely many solutions because the two lines are on top of each other, so they're intersecting at an infinite number of points. Now here's the weird part. You're not actually going to have to write all of this on MyMathLab. They already write it for you. But for the solution set, in other words, the way you write the solutions is you actually write this weird notation called set builder notation. So what you do is you write a curly brace, okay, and then you write x comma y. So parentheses x comma y, that's the set of all points x comma y. Then you write a vertical line. That vertical line is just like a divider. It means such that, okay? And then what you do is you just go ahead and write one of the original equations. So the first equation that we had was actually 1/4 x minus y equals 4. So we're going to go ahead and write that here. Okay, so we write 1/4 x minus y equals 4. And then you put another curly brace at the end to show that that's the end of the set. Now what this represents is because there are an infinite number of solutions, because the lines are right on top of each other, all the solutions have to be in the form of either the first equation or the second equation, because they're basically the same equation, they're just written in different ways. Okay? And this is just saying it's the set of all points such that the first equation was true. That's all it's saying. Okay, which is going to be an infinite number of solutions all along that line. And then there's also another way of writing it. Because the two equations are basically the same equation, because the lines are right on top of each other, they're basically the same line, you can also write it as the set of all x comma y. And then you write the vertical line, which means such that, or it's just like a divider to separate it. And then you write the other equation. So what was our other equation? The other equation we had was x minus 4y equals 16. Okay, so x minus 4y equals 16. And then you put another curly brace. So I know that's a lot to write, but the nice thing about MyMathLab is you don't have to write any of that. You just have to click, it's multiple choice. So you're going to click the button that says all of this. There's only going to be one button that says all of this, and so that's the one that you're going to click. It took me a while to write it down, but actually when you're doing your homework, if you get something that's always true, like 4 equals 4, or 0 equals 0, or 1 equals 1, anything where you're setting a number equal to itself, that's always true. So that means that there's an infinite number of solutions, and they're basically the same line. Okay, and then the way you write the solutions is you write this curly brace, the set of all x comma y. So the set of all points such that the first equation is true, or the set of all points such that the second equation is true. Okay, it's just a long way of writing that there's an infinite number of solutions. Okay, and we aren't going to be doing solving systems by graphing, but I did want to talk about what these three cases look like graphically. So we've done a total of 5 examples, but for the first 3 examples, we had just a single solution, okay? And I wanted to talk about what all these cases mean graphically. So graphically speaking, there are 3 cases. There are 3 cases for the number of solutions to a system. Okay? There are 3 cases for the number of solutions to a linear system. And remember, that's a linear system of equations. I'm just not saying that because I'm tired of writing so many words. Okay. And we've actually seen all the 3 cases. So if we look at the first 3 examples that I did, for the first 3 examples, let me go all the way back up to example number 1. Example number 1 was a point, x comma y. That's considered one solution because it's one point. And then for example number 2, we also had a point, 2 comma 7. That's considered one solution because it's one point. And then for example number 3, we had a single point, negative 1/5, comma 43 over 5. So for the first 3 examples, that's considered one solution for each of those. Okay, so that's actually the first case, and that's the most common case. So case 1 is what we saw for the first 3 examples, which is one solution. And what does that look like graphically? Well, graphically, you're just going to have 2 lines that are diagonal. Well, they're usually diagonal. They don't have to be diagonal, but they usually would. They would either have to be diagonal or they would have to be horizontal and vertical. So it's one of those. But anyway, because they only have one solution, when I say a solution, that only means one point. One point of intersection. And because they're linear systems of equations, each equation is represented as a line. So that one solution is right there. So that's 1 point x comma y. Okay, and that's the most common case. We saw that on our first 3 examples. That's where you get a number for x and a number for y. Now, what do the last 2 cases look like? Well, for example number 4, we got no solution. Now, for example number 4, at the end here, we got an equation that's never true because negative 24 and positive 23 are different numbers, so they can't equal each other. So these are never true, so those are not equal. So because it was never true, I said there's no solution. Now, why does it mean that? Well, the reason it means that is for case 2, that's where you have no solution. But what is that going to look like graphically? No solution means you're going to have no points of intersection. So you have 2 lines, but there's no points of intersection. Okay, that's how you get an equation that's never true, because the lines never intersect. So I mentioned it earlier in the video if you were listening. So what does that mean? Well, if the lines never intersect, that means they have to be parallel lines. Okay? So usually they would be diagonal lines, or they could be 2 horizontal or 2 vertical lines. But what's important is that they're parallel. So they never intersect. So these are actually, this is what it would usually look like graphically. They're going to have to be parallel lines because to have no solution, they can never intersect, and parallel lines never intersect. Of course, unless the lines are right on top of each other, in which case that brings us to the third case. Okay? But if you have parallel lines that never intersect, no points of intersection, that's no solution. And whenever you get an equation like that where you get nonsense, like 0 equals 1 or 7 equals 5, those are never true, so there's no solution. Okay, so that was case 2. That's what we saw for example number 4. And then for example number 5, we saw the third case. And we said there were infinitely many solutions because 4 equals 4 is an equation that's always true. The number 4 always equals itself. So this is always true. So I said there are infinitely many solutions, and we can use either of the equations because they're basically the same line. They're lines right on top of each other. Okay? So case 3 for the number of solutions is where you have infinitely many solutions, or an infinite number of solutions. That's what that means. Okay? Which basically just means you have two parallel lines that are directly on each other. Okay, so what's that going to look like? Well, if I do the first line in blue and the second line in green, you might have two diagonal lines, but they're basically the same line. Okay, they're right on top of each other. It's kind of hard to draw, but I'm trying to draw two lines right on top of each other so you can see both of them. Okay, that's probably about as good as I'll do. Okay, so infinitely many solutions. If you get an equation that's always true, like 0 equals 0 or 1 equals 1, that means the lines are right on top of each other. So that basically just means they are the same line. So there's different ways of writing the same line. You can write the same line with different equations, and that's what you're seeing there. And if they're the same line, of course they have an infinite number of points of intersection. Because if you just look, 1, 2, 3, 4, but you can always just count more and more. So there's an infinite number of points where it intersects. Okay, so that's it. So that was everything. Thanks for watching.